page 3. So it says graph the following linear equations, identify slope, y-intercept, and graph. All right. So you will have to be able to graph an equation from slope-intercept form and graph an equation from standard form, okay? Now, right here, what we ask you to do is identify the slope and the y-intercept. Now, these are written in slope-intercept form. Now, the name of the formula implies what's happening. So remember that these are written in slope-intercept, where m is my slope and b is my y-intercept. Okay, so with that in mind, the coefficient or the number in front of x is your slope. Okay, and the y-intercept is the b. Now, remember the sign in front of the number goes with the number, so -1. When you go to graph these, you are going to use this information right here to graph. So when I graph, the y-intercept is at -1. This can also be written as 0, 1. Sorry, -1. So what that means is at over 0, down 1, that's my first point. And then I'm going to use the slope to tell me where to go for my next point. Now remember that slope is rise over run. Rise over run. Now you may say, well, where did you get that 1? Well, as a fraction, what's 4 divided by 1? 4 divided by 1 equals 4. So I just changed the 4 to be a fraction so I know what my rise is and I know what my run is. So I'm going to rise 4. 1, 2, 3, 4, and run 1. There's my next point. Okay? So I take my trusted straight edge and then I graph my line. Just like that. Now we look at our next one. Notice there is no x value here. So if you're thinking about y equals mx plus b, there is no m and there is no x. When that happens, right, it's 0. Okay, and my b, remember the b is the number that is all by itself, -1, or 0, -1. So I'm going to put a dot at -1. Now, what kind of line has a 0 slope? Hopefully you said horizontal line, because this is a horizontal line at -1. Okay? All right, let's look at the next one. Remember that the slope is the number in front of x, or it is the coefficient of x. Coefficient means number in front of letter. So the slope is -1 over 3. Okay, just because these are written in backwards order does not mean this is the slope. That is not the slope. The slope is the number in front of x. So it's 1/3, -1/3. Didn't realize. Oh, okay, never mind. Keep going. Now my b value then, +1. Okay, or 0, 1. So at 1, I'm going to put a dot. And then this is -1 over 3, which means I need to go down 1 and to the right 3. Okay, and then I draw my line. All right, the last one. This right here is written in standard form. Remember, standard form looks like this. When it's written in standard form with your x and y on the left, you need to solve for y to figure out what your slope and your y-intercept are. So what you can do here is -2x on both sides. I'm left with 2y equals negative 2x plus 6. And then you have to divide by 2 because you're trying to get y by itself. Remember, when you divide by 2, you divide each term by 2. And I get y equals negative 2 divided by positive 2 is negative 1x. 6 divided by 2 is 3. Now this is written in that slope-intercept form that we like. And I know that the coefficient, the number in front of x, is negative 1. That's my slope. And then the number that's by itself is my y-intercept. Okay. Remember, if you need to change this to a fraction, put a 1 underneath. All right. So I'm going to start at 3. This is negative 1, so down 1 and to the right 1. Down 1 to the right 1. Okay, so there's my line. And there we go. Okay. Now, we have to find the x and y intercepts and the slope. Okay, so here we gave you an equation and asked you to tell me what the slope and intercepts are. Here I'm giving you the line and asking what the y-intercept and x-intercepts are in the slope. Okay, so basically you're just looking and telling me, where does this touch the y-axis? It touches the y-axis at 0, negative 2. Where does it touch the x-axis? It touches the x-axis at 4, 0. Okay, and what is the slope? How do I get from one point to the next point? Well, I have to rise 2, and I have to run 4. You can reduce that to 1 over 2. Okay? So let's try again. Where is the, you can do this in any order really. What's the x-intercept? 1, 0. What is the y-intercept? 0, 0, 2. I got carried away with that. And then what is the slope? Be careful with this one. I have to rise 2 and then run 1, but I went to the left. When you go to the left or you go down, it is negative. So please be careful with that. So my slope here is negative 2. Also, if you remember Mr. Slope Guy, he looks like this. See if I can remember. Oh yeah. Right, Mr. Slope Guy? Undefined, 0 slope, positive slope, negative slope. Okay? So all your positive slopes will look like this line. Negative slopes are going down, undefined slopes are vertical lines, and 0 slopes are horizontal lines. Okay? All right, let's look at the next one. This right here is a vertical line, right? And like I said before, we know that all vertical lines have an undefined slope. Okay? We know that it touches the x-axis at negative 3. Now notice this runs parallel to the y-axis, so it's never going to touch the y-axis, right? If it never touches the y-axis, we're just going to write none here. Now, please do not write 0. If you write 0 for a y-intercept, you're telling me that this line touches this line at 0. 0 is an answer. and it's the wrong answer in this case. So make sure you do not write 0. You have to write none. All right. We'll do this last problem. We'll squeeze it in. The function g equals negative 3h plus 27 represents the number of gallons g that remain in the car's tank after h hours of traveling at 70 miles per hour. What is the independent and dependent variable? Okay, this is very important. All right, so the independent variable is going to be the number, the input. What are we putting into this, right? So think about this. Number of gallons that remain in the car's gas tank after hours of traveling, okay? So what are we putting into this? Where are we putting gas in? Are we putting hours in? And actually, we are putting hours, okay? And the dependent variable is number of gallons that remain. So gas or gallons, all right? So the independent variable is going to be normally your x. Notice this is written very similar to the slope-intercept form, right? So my independent variable is your x and your dependent variable is your y, all right? Now the first question says, how large is the gas tank? Now this right here, what you are supposed to do is think about if I had filled up my car and drove nowhere, right? So 0 hours. The answer here is 27 gallons. Okay? We know that because what we're doing is what would happen if I filled up my gas tank and went 0 hours. That's how you know how large your gas tank is. Okay? How many gallons are left in the tank after 4 hours? So they give me this information right here, 4 hours. So I go back to my equation. I have a G and an H. Where do I put the 4? Well, I plug it in for H. So negative 3 times 4 plus 27 equals 15. 15 gallons. That's how many gallons are left after 4 hours, because I had to use 12 of them to get to where I'm going. And how many hours will the tank be empty? Well, what does an empty tank look like in math? An empty tank looks like 0. I have no gallons. And it's asking how many hours? So negative 3h plus 27. If you solve that out, divide by negative 3, I get h equals 9. So 9 hours is how long it's going to take to empty my tank. And then it says, how many gallons per hour does the car use? This is slope. Remember, slope talks about rate of change, and the rate of change is 3 gallons per hour because it says 3 gallons per hour, and we start with 27 gallons. Okay? All right. Now, I'm going to do the last 2 and just show you. They are not on your test, but they're good to know. Okay, for this first one, when the equation is this, where P is a constant, which means it has no letter, is graphed on the coordinate plane, and the line passes through this point, what is the value of P? So basically, this is your X value, this is your Y value, and basically just plug it in. So I put a 1 in, and I put a -2 in, I solved and got 11. Okay. For the next one, this one is not actually as hard as you might think it is. You set this up sort of like a chemistry problem where it's 400 characters per second. Okay. Now, because characters are on the top, I have to make sure characters are on the bottom for the next one. So it's one word for 5 characters. Now, because characters are here and here, I can cross them off. I'm left with words per second. I'm looking for words per minute. So I have to then, I need to keep words on top and I need to get minutes on the bottom. So seconds, it's 60 seconds in 1 minute. So the seconds and the seconds cross off. So I'm left with words per minute. And then you just multiply straight across. 400 times 1 times 60, and then 1 times 5 times 1. I end up with 24 with 3 zeros, 24,000 over 5, which ends up 4,800 words, okay, per minute. So that's how you do that problem. All right, cheers.